Maths, Unit 3, Practice Assessment, NAB 3, Outcome 3 on logarithms. Now, there are 9 marks available in this outcome, and in order to pass it, you need to get 6 out of those 9 marks. Now, logarithms aren't nasty at all. Logarithms are just the inverses of the exponential. You have exponential functions, which means the variable, the number you're feeding into it, goes into the power position. So something like f of x equals 2 to the power x is an exponential function. The variables go into the power position. Now, all functions have got inverses. Sine, inverse sine, or arc sine. Square, square root. The inverse of the exponential function is the logarithmic function. This number in the exponential function, the number that all the powers are based on, is called the base of the exponential function, and that will remain the base of the logarithmic function. To show the inverse in action, it could be something like this. 2 to the power, 3 equals 8. If I put in power 3 into powers of 2, I get out the answer 8. Now, the reverse of that, the inverse of that would be, well, what if I know the answer is 8? How can I figure out what number was put in? That would be the inverse function. Now, the wording for that inverse function would be this. This thing, whatever it is, says, what power of 2 gives 8? You could write it down that way. What power of 2 gives, whichever number I want to try, gives 8. Let's put a little s in as well. Now this part here, what power of 2, is written as log base 2. Log base 2 simply says, what power of 2 gives me the number that I'm going to operate it on? What power of 2 is 4? What power of 2 is 64? What power of 2 is 8? And that's the best way to read that. Log base 2 says, what power of 2 is 8? And of course the answer to that is, what power of 2 is 8? Well, that's an operation. It's operating on 8 to tell you what power of 2 was used to produce it. That was power 3. So there's the first thing you have to remember. Logs are powers. They're powers of numbers. So that means you can get the basic equation that changes one into the other. If I've got a to the power x equals some number y, you could just call it for the result. That's an exponential form, because the variable I'm putting in is in the power position. Then the opposite would be, to get back to x, I'd have to undo the exponential. So that would be log base a, acting on y. Notice the part that's been removed is this function, this a to the power. What's the inverse of a to the power? It's this. It's log to the base of that a. And vice versa, of course. You just have to be careful you don't try and remove that x from the top, because that's what you're used to doing normal power terms. If I've got x squared equals y, then you think, oh, it's that bit I want rid of. That's the wee nasty extra bit. So that'll be the opposite of power 2, which is power 1 upon 2, or square root. Just be careful here that the variable that's going in is the power. The power is the variable. That's why it's an exponential. So it's not that x that's going to be removed to the other side. It's this part here lifting it up. It's this exponential function you don't want. So to remove that from one side, just to leave the x it was acting on, sometimes it's clearer when it's written as, but you can't do it with an a, something like that, exponential of x. But that only applies to one specific base, the base e. But it's certainly clear that way. Exponential of x will be on the other side. Inverse of that will be the logarithm to that base e, which is often written just as ln, natural log. Sometimes it's easier when you see that exponential of x, because it looks quite simply like any other function, like sine of x. So the result will be x equals inverse sine. Exponential of x, so I'm left with the x, and that'll be inverse of exponential, which of course you're right as natural logarithm in this case. but that only applies to the base e. If it's a general base, it would be written here, and that's the part that you're going to remove, the base of the power. Will go across as log base a. Now, thinking of log as what power produces this number, then no matter what the base is, so log of any base at all, if you've got the log of a and it's the same number here, it's like saying log base 2 of 2, what power of 2 produces 2? Log base 3 of 3, what power of 3 produces 3? Log base a of a will always produce a 1, because a is a to the power 1. Another very common would be, what about log base a of just 1? That says, what power of a gives me the answer 1? What power of 2 gives me a 1? What power of 3 gives me a 1? Well, anything to the power 0 is 1, so log base anything of 1 would be 0. Those are two very common ones that you would remember. Notice the equivalent. Inverse statements. If I want to write just a equals, if I want to remove this function acting on it, log base a, then I would have a equals the inverse of log, which is the exponential on the other side, and that would be powers of a. So that says a is a to the power 1. Of course it is. Same here. If I wanted to write that as 1 equals by removing that function acting on it, log base a, then the inverse of log base a is a to the power 0. That's right. A to the power anything is 1. Further laws of logs would be what happens when you add logs together. What about log a 4 plus log a 5? Well, logs are powers. You add powers when you're multiplying terms of a common base. And the first rule of logs would be adding logs gives you the log of the product of those. It's the log of 4 times 5. That equals the log base a of 20. If you're adding logs, then that will be the single log of the product. And if you're subtracting logs, log a 20 minus log a whatever 10, logs are powers. If you were subtracting powers, that would involve a division of the terms. So that would be log base a of 20 divided by 10. That's log base a of 2. One extension of this first one would be if you keep adding the same logs all the time. If I had log a of some number, just call it b, and another log a of that number b, and another log a of that number b, then there's two ways I can look at that, because those terms are all the same. I could either say I've got 3 of them, I've got 3 lots of log a of b, which I certainly have, or I could use that rule for addition, which says, well, that's the same as log a of b times b times b. When you're adding logs, you multiply them, so that would be b cubed. Notice what's happened there. If I've got an expression with some coefficient, multiplying it, that can pop inside as a power. Generally you learn it that way. N log a of x is the same as n log a of x to the n. You can pop the powers in and out, and that's very useful in solving equations later. Applying a log to a power enables you to pull that power off and put it at the beginning. So that doesn't appear in the NAB. So, what are the questions here? Well, question 8, the first of the ones in outcome 3, is in 2 parts. First part's worth just 1 mark, and the second part is worth 4 marks. The first part will simply be to either add or subtract 2 logs with some general base just called a. So it may well be something like log a4 plus log a6. Or it might be log a4 minus, in which case the second question will have the plus. Well, that's fairly trivial. That's just log base a of, if you're adding logs, you're adding powers, you must have been multiplying terms to add powers, so it'll be log a of 4 times 6, or you could state that straight away as log a of 24. 1 mark for that question. The second question is a bit more involved. If that's a plus, it'll involve a minus. It'll be the same thing, except you'll have some number multiplying one of the logs. So you can use that rule of popping it in as a power. And then combining them to get the log of some number. But there'll be one step further in that you'll have a given base, so you can actually evaluate the logarithm. Now, because you can use calculators in the unit, there's no marks in part B for the 4 marks simply for putting the answer down. That's obvious, because you could just type that expression into your calculator and it would give you the answer. So all this working has to be set out. So it could be something like, for instance, 2 log base, and then it'll be a fixed sum base or other, log base 5 of 10, minus, because I had a plus in that one, log base 5 of some other number, like 4. And this will be worth 4 marks altogether. Well, the first mark will be for using one of the laws of logs, which is, if I've got a multiple of a logarithm, I can pop that inside as a power of the number it's operating on, minus log base 5 of 4. So there's 1 mark for having carried that operation out. The second mark would be for realising if you're subtracting logs, then you'll be dividing the numbers they're operating on. So that'll be a single log of 10 squared, which you may as well write now as 100, divided by 4. That's the second mark. Now the next mark is a bit unclear, because the third mark is for simplifying the expression, which in this case would be a 25. But there you are. So there's 3 marks to getting it down into a logarithmic expression of a fixed number. And the last mark is for evaluating that. Now, there's only 1 mark for this, but it's meant to be to demonstrate you know the laws of logarithms. A coefficient becomes a power, add or subtract becomes multiply or divide. And then what they call this, one of the laws of logs, log base of A equals 1. But that's a simple axiom of what log means in the first place. Strictly speaking, you could just write that down straight away and say log base 5 of 25 simply means what power of 5 was used to produce this number, and that's a 2. So strictly speaking, that's all that needs to be done. In general, you would justify this by saying, you'd say, well, log 5 of 25 actually means you've got log 5 of, and since it's talking about powers of 5, express that as a power of 5. And then you could say, well, that power can come to the front, so it's 2 times it. So it's 2 times log 5 of 5. And since log 5 of 5, using that rule, is a 1, that gives the answer 2. But then, since calculators are allowed here, if it was a case where you weren't allowed a calculator, then that step must have been done by understanding. But because you can just type that in, maybe you should, if it was a case of not just log 5 of 5, if it was a case of log something of some other number, then you should put down the justification of it, because otherwise you could just have used a calculator. Whoops, I should have mentioned in question 8 part B, in some of the NABs, part B appears in 2 forms. The first part of part B simply says evaluate something or other, 3 log 4 of 7 minus log 4 of 2, for instance. And then the second part, which doesn't end up as log 4 of some nice power of 4, especially just a 4. And in cases like that, and that'll just be off the 3 marks, there'll be a second part which will say something like evaluate log 5 of 5. Log 6 of 6 for 1 mark. You know, the part that would have been here if that had turned out to be a nice answer. So question 9 and question 10 are just on using the inverse functions. Question 9 will say something like, and it'll be the base e, the natural number e. If e to the x is something like 9.5, find what x is, just so that you can use the inverse function to arrive at that. Just like it was to say sine of x is 0.4. How would you find x? Remove that by applying the inverse to both sides. It's the same as here. How can I get to x? Remove that exponential function by applying the inverse, which is log base e, or ln if you like. So log base e of 9.5. Now that's worth 1 mark. So the other mark will be for just pressing the buttons. Now log base e is also written as ln, and that's the way it'll be in the calculator. So to work out that, you would simply press ln of 9.5. And you get 2.251, and it carries on, and then just round it off as appropriate. Usually 3 significant figures does. So 2.25. That's the second mark. Question 10 will be a similar one, only with a log at the front. So it could be something like log base 4 of something. But usually there's an extra little part, and it won't just be log base 4 of x, it'll be x plus some number or other, or minus some number. Say I've got log base 4 of x minus 3 equals whatever, 3. 2 marks again. First part will be for removing the function by applying its inverse. The inverse of log base 4, to leave you just with this part, is 4 to the power. Remember, it's an exponential. That 4 is the base of it, so that 3 will actually lift up. It's 4 to the power 3. Exponential functions always look like this. The numbers that they operate on go into the power position. So that 3 is lifted up and the 4 slides underneath there. That's the first mark for applying the inverse. Log base 4 goes to 4 to the power. And finally, take the 3 across and add. Well, 4 base 3 is 64. So add on the 3 and you've got x equals, is that pretty skinny 3, will be 67 for the second mark. So they're fairly straightforward. Just apply the inverses. So try the questions. So the first one. Subtracting logs, like subtracting powers, must have come from a division of the numbers. So that'll be the same as log base A of 15 divided by 3. Which is log base A of 5. The mark being for the division, but certainly finish it off to get the answer. In the next one, now there's 4 marks for this. Well, the first one would be use that law of logarithms, where if you've got a multiple of a log, you can pop that inside as a power. So there's 1 mark. Next part would be if you're adding logs. Adding powers must have come from a multiplication of numbers. If you're adding logs, then that'll be the same as the log of the product of them. That'll be the log of, now 2 to the power is 8, so that's 8 times 8. That would be the second mark. Just tidy up what that stands for. That's log base 4 of 64. And according to the marking scheme, that's the third mark. Now, whereas I think that shouldn't be the third mark should be in showing you understand what that means. Now I could go straight in and say, what power of 4 is 64? 3. And that would certainly be correct. However, since you could use a calculator here to evaluate that, I'll show the working, I'll show that understand that means what power of 4 by saying, what power of 4 is this? Well, 64 is 4 times 4 times 4. That's 4 to the power 3. Which is, taking that 3 out, 3 times log base 4 of 4. And log base 4 of 4 is 1, so that's 3 times 1, which is 3. Now there seems an awful lot of working there to get that final mark. But it's probably safer to do that, because otherwise you could just have used your calculator without understanding it at all. Normally, especially if it was a paper 1 question, if I saw log base 4 of 64, I would just think, what power of 4 is that? That's 3. There you go, answer 3. It's only because here you could have used a calculator that I think I'll plod my way through all of this to show it actually comes to a 3. Number 9, oh, that's the one I accidentally used in the example, but since I've already printed that sheet out, I'll just have to use it. So, e to the x, to get down to the x to remove the function, the exponential function, it'll be log base e of acting on 9.5, or if you like, ln 9.5. And then pressing the buttons, of course, gives you, as before, this was just daft, 2.5129 and so on. So given at least 3 significant figures, 2.25. First mark for applying the inverse function, knowing the inverse of exponential is log, and the second one for pressing the buttons. And number 10, for the final 2 marks, solve that equation, find what x is. Well, first of all, remove this function to leave just the x plus 2, and the inverse of log base 3 is 3 to the power, is the exponential, so it's 3 to the power 4, which is the 3, that's almost where the confusion comes. The 3 doesn't go up as a power, it's powers of 3. log base 3 says what powers of 3? 3 to the 4. And then take that 2 across and subtract. So there's the first mark for applying the inverse. And then subtracting 2 from that. Well, 3 to the 4 or 9 nines are 81. Subtract 2 means x is 79. That's the second mark. And that completes all 9 marks for outcome 3.